Well, as Martin mentioned, Stan's very fond of cricket, so I thought what I'd like to do for this talk is call it 25 Not Out, referring to 25 years of both the geographical analysis machine and the modifiable area unit problem. In fact, now I think of it, I think they're actually older than 25 years, but I like the number 25 more, so we'll stick with that. But basically what I want to talk a bit about is, first of all, my experiences and memories. I was privileged to have Stan as my PhD supervisor, and he was an excellent supervisor. One of his great ideas was to argue with me a lot, and I sometimes get very frustrated with my own PhD students that they don't tell me I'm wrong more often. And I think PhD students, you want to tell your supervisors that they're wrong more often, and supervisors argue back. That's the way to get ideas going. And it was a very creative and exciting time. And I suppose what I want to talk about is why I think some of Stan's ideas were so exciting, and how I think they've influenced the world since then. And okay, I've used a cricketing analogy. While we're still on physical activities, there's a photograph of myself and Stan in, I think, about 1991, I think in Oxford there. And as I say, I did learn a great deal from Stan, and so I've used this term here, a voyage of discovery. One of the other things you don't know about Stan is he's actually a magician, because he managed to turn me into a geographer, and that was really quite good, because I came to study a PhD with degrees in mathematics and medical statistics, no experience of geography whatsoever. So anytime I ever think like a geographer, I'll give some sort of impression of being a geographer. That's probably thanks to Stan. So I'll talk a bit about why I think this was such an exciting time. First of all, I think one of the things we were doing a lot in that time, in the time that I was with Stan in Newcastle and with the other group there, was that we found a lot of new technologies. Things actually were changing quite a lot. Computers were getting a lot more powerful. These days, they wouldn't be particularly powerful, but in relation to what they were before, they were getting more powerful. We're also thinking about new methods, new ways to do things, new ways of actually approaching our geographical problems. And so I think we got introduced to a lot of new methods. And probably most importantly, in the culmination of all of that, loads and loads of new ideas as well, as I say, mainly emanating from Stan. So what about the new technologies? Well, one of the things, worked for a time at Newcastle in something called the Regional Research Laboratory. And laboratory was a really good analogy, because we used to use the computer to do experiments. As I say, before I had this sort of mathematical background, there was a lot of theory and dealing with modelling things with equations, looking at the properties of the equations and so forth. Stan said, no, get the computer, try this out, try running a program, see what the numbers come out, see what it looks like. So our computer was a laboratory. We were like chemists. We actually tried things out. We didn't just write the equations on the blackboard. We actually did things with it. And for example, loads of PhD students, including me, were doing lots of sort of Monte Carlo simulations and related things. And that's something that I think all of us were doing quite a lot of, and Martin's alluded to that as well. So as I say, we were more like chemists, and we made sort of bangs and smells in the laboratory, except they weren't literal bangs and smells, but I would actually say things like breaking the plotters or annoying the computer services stuff were equivalent to bangs and spells. And Martin spoke a bit about this checkpointing approach, where you run a program for a certain amount of time, write out its results and resubmit. And some of the quite entertaining things that happen when they don't work properly, mainly that they fill the computer job queue with thousands and thousands of jobs, which the computing staff then have to delete manually, because there wasn't a way of just deleting the entire queue at one time. So some poor guy had to sit there for hours on end, removing one job after the other. I remember one particularly spectacular version of this, managed to do this, got called down to the computing centre, to the help desk, and they sort of explained to me the error of my ways. And the guy was actually quite sympathetic and said, well, okay, you're obviously trying to solve some sort of problem. And then he sort of phoned down to the computer operating room, where the person was actually deleting all these jobs. And I only heard one side of the conversation, but it says, no, we don't want to do that to him, we want to help him, was the comment. So that was one of my sort of lasting memories of this sort of experimental aspect of things. And the reason I'm also saying 25 not out, if you go back forward now to now, that was about 25 years ago, in those days it was pretty unusual to do all this sort of very much computing-led experiments. But you can see how influential it is. There's loads and loads of different ways that can be done now. if you look at things like IPython, interactive Ruby as programming languages, or R, all of those encourage you very much to sit at the terminal, try things out, draw pictures of what happens and so forth, and to experiment. This laboratory idea is really taken forward. But Stan was able to do this just using Fortran and a thing called interactive Fortran in the 1980s at the time I was there. And there was, I think, lots and lots of evidence of that happening. But if you look around now at some of the presentations, I'm seeing more and more people actually writing code to solve problems rather than just using things from packages. There's a lot more sort of code-based solutions to things these days. He also introduced me to lots of new methods, and these are all things perhaps that Stan was advocating a bit after he'd moved on, but nevertheless there was a lot of innovation here, and I think Stan enthusiastically looked into the computer science community, to any other kind of community, for people who might be able to come up with innovative approaches. So you're probably going to see quite a load of these things this afternoon, but a couple of very important things that Stan was involved in, and probably two of my favourite ideas. And one of the things that characterises this and the other one is that it's about real-world problems. Stan would always try to apply these geographical techniques to genuine issues that weren't just of interest to academics. They'd actually be useful in a lot of ways. And the modifiable area unit problem is one of these. Again, Martin has alluded to that. In a nutshell, if you do some sort of analysis of data, if you aggregate the data to a different set of geographical zones, you may get very different results. And a lot of people overlooked that when they were doing analysis at that time. And this is one of the sort of very clever things that Stan does. He sort of says, hang on a minute, okay, you solved that question, but was that really the right question to solve? You know, you should have been asking a different one. And I think that very much happened with this is the famous modifiable area unit problem publication, and that's the first page of it. Now, you can't really see that very well, but one of the things that he's doing there, the last part of it says, towards a new methodology for spatial study. And I think that's very important to characterise the way Stan looked at things. He quite often say, well, actually, no, everyone's not really approaching this in the right way. They're asking the wrong questions, they're doing the wrong things. And the response to this is to try to set up some kind of new approach, new way of doing things. And, okay, lots of people can do that. Is it still having influence? Well, yeah, this is an article from 2011 about using zoning systems based on Stan's thoughts about the effects of zoning, in this case for designing zones for the 2011 census. So basically these ideas, again, 25 not out, the ideas are still lingering, and that's another example of this being used. And thinking about not just the fact that when units change you get different results, but about how you would design zones to get the most useful results, and that's still being done. So another real world problem that Stan looked at was something to do with clustering. Basically, if you've got certain kinds of data, you want to see whether it's clustered like the points on the top or random like the points on the bottom. And that can be important if you're looking at, say, the incidence of disease. You want to see, it helps you understand quite a lot about the nature of that disease if you see it clustering in certain areas, what might be causing it, and so forth. It helps you to understand it. If we went to the sort of pre-Stan days, this might be a typical way you do it. This is based on the mean nearest neighbour distance, whether each point's closest neighbour was more or less than you'd expect at random. That's the test statistic you can use, that big long equation there. Now, one interesting thing about that is, well, first of all, the above formula is only an approximation, so it's only that long. The real answer's that long, but I don't know, we couldn't get big enough slides or something to put that on. The other problem, again, is the above formula is only an approximation for points in a rectangle. Now, as I say, Stan made a geography out of it, and I'll prove it now, because I can look at things like we were looking, for example, at cases in the northeast, and look, the northeast is not a rectangle, so I'm learning geography gradually. There we are, and the northeast is not a rectangle. And another problem, even if the two problems I mentioned there were solved, the points might cluster anyway, because if you've got two different towns, say, and nothing in between, you'd see clusters of points like that just because of the underlying population cluster. So what you're really looking for is, if you're going to get an area like the northeast of England, you want to be able to decide whether things were clustering above and beyond they would do just to normal settlement patterns, and you would want to be able to work in an area that isn't a rectangle, but it's actually Newcastle or something like that. So the important thing, again, this is where Stan's very clever. Again, he decided, well, you're looking at asking the wrong question. And there is this very, again, as a mathematician, there's this very sort of idea to set up problems that we find mathematically interesting and try to come up with solutions for them. But as I'd like to point out, this is about, clusters of leukemia. It's a serious illness. It's not puzzle corner. We've got to actually try to solve this problem. It might be a messy solution, but it would be a solution to the right problem. And furthermore, we'd want to know, as I say, where are the clusters? Rather than just generally, is the process clustered? So that test before said, yes, this process exhibits clustering. No one wants to know that. They want to know where the clusters are. So the problem is, A, they were using the wrong techniques before for this sort of problem, and B, they're asking the wrong questions anyway. And Stan's very good at saying, you're asking the wrong question, and you want to ask this question instead, and this is a way of solving it. So that brings us to the geographical analysis machine. And again, with time short, but there's a varying population in an awkward shape, so where are the clusters then? Messy problem, but the actual one that's relevant. And that's where the geographical analysis machine comes along. This is an example of that. Now, I know this has actually got Cumbrian, whereas my earlier map didn't see, so I'm learning geography gradually, but you can see there, this is sort of the typical output of the geographical analysis machine as a way of finding clusters. It essentially scans around looking for statistically significant excesses and marks them where they occur. But it looks everywhere rather than to try to find where the clusters are, not just saying that things are clustered. And since then, I can think of lots of different things that were influenced by that idea. I think all of these, to some extent, were influenced by this sort of GAM idea of having a sort of scanning approach where you look for where the anomalies are, or looking generally by scanning to see how things differ in different localities. And in fact, this time, I would say that rather than using the huge fonts I've been using before, if I was going to put all of the things I think were influenced by Stan's idea there, I'd have to use an absolutely minuscule font. It'd be microscopic to fit them all on there. That's just my limited imagination of 6 I could think of quickly, but there's loads more. And so I'm coming towards the end now, but I think, as I say, my striking impressions of Stan was his ability to point out when people were asking the wrong questions, and also to come up with new ways of answering the right questions when he worked out what the right question actually was. This is actually a quote about complexity from a book in O'Reilly Press by someone called Alan B. Downey, which interestingly definitely does use this sort of laboratory approach. And he says that he sees complexity as a new kind of science, not because it applies the tools of science to a new subject, but because it uses different tools, allows different kinds of work, and ultimately changes what we mean by science. Well, in a sense, that's how I sort of see the way Stan operating. He tended to come up with an entirely new approach based on computation rather than sort of approximation and mathematical modelling. He introduced this idea of computers to search for anomalies, and this played a key role in the movement to local statistics, and as an alternative to just these whole map statistics. Well, I know that term paradigm shift gets perhaps overused, but I think there's something of that here, because what he did, as I say, is he changed the questions, not just found answers, better answers to existing questions, and he came up with a whole load of new tools that just were like nothing I'd ever seen before in my life before. So I suppose my 3-word tribute to Stan. Nice one, Stan. Thank you.